this is the part 2 of the parabola in which we are going to find its parts, and so we graph the parabola with a given vertex which is not in the origin. So we have here an example which is x squared equal to negative 8 times y minus 1. So again, we start with the opening of the parabola. So the opening of the parabola, since we have there an x which is squared, so orientation will be on upward or downward only. And then looking at our negative 8 here, which is multiplied to your non-squared variable. So since that is negative, then that means to say that we are going to go for the downward. So opening of the parabola is down. So in the upward or downward orientation of the parabola, all you have to think of when you've got there a positive, opening of the parabola will be opening towards the positive y-axis. And once you have the negative, the opening of the parabola will go for the negative y-axis. Next one, we go for the vertex. Now the vertex here, you are to ask yourself if you've got there a number added or subtracted to first an x. So x here is squared. We don't have any number added or subtracted to it. So automatic, we have our coordinate for the vertex on the x coordinate as your 0. So next one on y, we have y is subtracted with 1. So again, since we have a number subtracted to your y, automatically we'll get the number. So since this is 1 minus 1, automatically you'll have here a positive 1. Because our format for the downward orientation of the parabola is x squared equal to negative 4a times y minus k for this particular example. Because you've got there a y and then a minus and a number. So if you are going to consider, we don't have an h here, so that's why we have a 0. Because supposedly there should be an x minus h squared. That's equal to negative 4a times y minus k. Since we don't have a number subtracted to that 1, automatically we have a 0 for h. And then we have 1 for our k. So if you are really confused on how to identify the vertex, especially if you've got a vertex which is non-zero, then you might think of, if you have a minus in here, automatically we'll have a plus or a positive 1 on our vertex. Or if you are going to really consider this one as factor on y minus 1, you can have it as y minus 1 and that's equal to 0, then our y will be equal to 1. So again, in any ways that you can find the vertex which is the correct one, that's really fine. Next one, we are going to plot our vertex. So our vertex here is at 0, 1. So 0 is x. So we do not move across to the left or right on our x-axis from 0. So that means to say that your 0 is somewhere here. Now, next one, you've got 1, which is on the y. So we have to move up because that is positive 1. We move up from 0, 1 unit. So that is why our point here is on this one. This is our vertex, which is 0, 1. So next one, we are going to look for the focus. So what do you think what will be the focus on that one? So finding focus, all we have to do is to find our A, because again, the distance from the vertex to the focus is A. Now, going back to the equation, whenever you've got an equation like this, our a is always our 4a is always multiplied to our non-squared variable. So if we have here negative 8 that is being multiplied to y, our negative 8 is our negative 4a for this particular equation. So again, we have this format. If you try to look at this is the formatting. So we have x squared equal to, and then we have negative 4a times y minus k. So equal to negative 4a, that is negative 8. And then we have y minus k, which is y minus 1. So 4a is equal to negative 8. Negative 4a is equal to negative 8. We divide this one by negative 4, and so with this one, our a is equal to positive 2. Now, since a is 2, locating our focus, since this one is downward parabola, all we have to do is to count 2 units from the vertex down. So again, 2 units from the vertex to determine the focus. So 1, 2. So this will be now our focus. Take note, focus is a point, so we have there the coordinate. This is also on x, which is 0, because we do not move across from the 0. So this is now 0, and then our y here is -1, because we moved from our y, which is equal to 0, down 1 unit. So we have that one as -1. So again, if you are having trouble with identifying the coordinate, then you have to really practice identifying the coordinate so that you will be able to have the correct answer for the focus and so with the vertex. Otherwise, if you don't know, then that will be incorrect. Next, let's go to the focus. So focus here, your answer must be in a coordinate. So we have 0 and then -1. So next one, let's go to the directrix. So directrix is a line. Now, directrix from the vertex, the directrix there has also 1 unit. They have the same, I mean 2 units. They have the same distance from our vertex to focus. So once you have vertex to focus as 2 units as the distance, then automatically the directrix there will also with the 2 units. So from the vertex, we are to count up, because your focus, we counted that one down. So we go opposite to that one. So from the vertex, we go up. So go up for 2 units. So we have 1, 2. So this is now where we are going to draw a line, a broken line. So there you go. Now, going over to the directrix, since that is a line, we are going to write the equation of the line there. So this line, the directrix here, is passing through the y-axis, because this is the y-axis. This is passing through our y-axis. So this will be now y. Y equal to the number that we passes through on that y-axis is 3. So y is equal to 3. That is our directrix. Next, let's go to the axis of symmetry. So axis of symmetry passes through our vertex and focus, and this divides our parabola into 2 equal parts, or identical parts. So we are to draw a line passing through our vertex and the focus. And this will be our axis of symmetry. Now, the axis of symmetry here is so identical with the y-axis, because our vertex is at 0, 1. Now, to write the line, the equation of the line there, because axis of symmetry is still a line. So to write the equation of the line there, we are to ask ourselves whether on this particular y-axis, what is that line that we passes through, or what is the line that it cuts through. So this particular line, the y-axis there, cuts through or passes through the x-axis. So that is why we have here x equal to, since this is very identical to the y-axis, and the y-axis passes through our x-axis at 0. So that is why we have x equal to 0. Now, take note on the directrix, if you've got a y in there, then you will have an x on the axis of symmetry. When you have an x here, then you have a y on the axis of symmetry. So that is how we identify the one. Next, we go for the endpoints of the latus rectum. So endpoints of the latus rectum, we always have to go for or start on the focus, and then we count the number of units. So how many units are we counting? Now, endpoints of the latus rectum, we have that one as 2a, 2 times a, as a distance from the focus to that particular endpoint. So we will now be solving our 2a. 2a is equal to 2 times our a is 2. That is equal to 4. Now, from our focus, we are going to count 4 units to our left and right. So we have here, the focus is here. We count 1, 2, 3, and 4. So this is where our endpoint of the latus rectum with our coordinate, which is, this is -4. Oops. This is -4, and so with our x is -4 in here, and then our y here is -1. So next one, we go for another endpoint. So from the focus again, we count 4 units to the right. So we have 1, 2, 3, 4. So this is where our endpoint of the latus rectum is. And then we have our coordinate for the one is on x, we've got a 4. And then on y, we've got a negative 1 still. So we have now the latus rectum as negative 4, negative 1. And we have also 4 and negative 1. So next one, we are to find the length of the latus rectum. So length of the latus rectum is this one here from the endpoint going towards the focus and so with the endpoint. So how much will be the distance from this point towards that point? So to determine that one, our length of latus rectum will always be 4a. So once you've got an a, you can multiply 4 and your a. So that is now 8. Or simply saying that one, whatever is the number here, multiplied to your y or the non-squared variable, then that means to say you are to get the absolute value of that one, and that is the length of the latus rectum. So that's why we have an 8. So from here, we are going to draw our graph. So from the vertex, we are to connect our endpoints here. And then from our vertex again, connect that one to the other endpoints of the parabola and draw an arrow. So this is how we draw our graph for our parabola. Let's go to another example here. We have y minus 1 squared equal to 2 times x plus 2. So from this example, we are to start with opening. So opening for this one, since our squared variable here is y. We have a square here, so y should be our basis for the orientation of the parabola. So it's either going to be sideways to the left or right. Now, to determine whether it's left or right, we are going to look at the number multiplied to our non-squared variable, and that is 2. Since 2 is positive, all we have to do is to look at where particularly on our x-axis is our positive numbers. So positive numbers are located on the right side. So our opening of the parabola is to the right. So opening, we have right. Next one, we go for the vertex. Now, this one here, if you are going to look back on our equation, we have that one as our y minus k squared equal to 4a, sorry, and then times x minus h. So this is our equation of that particular parabola. Now, looking at that one, once we are to identify the vertex, we must first know what is our x. X here are always associated to the variable x. So if you are to look at this one, this is with y. So you go over with x here. So x is with plus 2. So again, as I mentioned, you may negate this one to get your vertex. So since that is positive 2, then that means that is negative 2. Or you can consider this one as your factor. So you equate that one to 0 and then look for x. So our x here is equal to negative 2. Next, going over to the y. So y here is associated to our y variable. So again, as I mentioned, you are going to negate. So you have negative 1 for this one. So that should be positive 1. Or you can get the factor and then, or you can consider this one as a factor and then equate that one to 0 and solve for y. So there you go. We have our vertex. So vertex is at negative 2 and then 1. So somewhere here, this is our vertex with negative 2, 1. So next one, we are going to identify the focus. So we look first on our a value. So again, if you are to look at your equation, 4a is the one multiplied to your x minus h. So your 2 here is our 4a. So 4a is equal to 2. This will be divided by 4, and so with this one, so our a is 1/2. So next, we are going to count 1/2 unit to our, since this is to the right, we are to follow the counting for the focus on the opening. So if this is to the right, then you are going to count from the vertex to the focus to the right side. So from the vertex here, we are to count 1/2. So that means to say this is the location of our focus. So which is negative 1 and 1/2, or this is 3/2. So negative 3/2, and then on y, we have that one as a 1. So next one, we are to count for the vertex. So let me write this one as our focus. So next one, let's go for the directrix. So from the vertex again, we are to count the same unit to the left side. So this is now vertex. You count 1/2. This is our line, which is our directrix. So writing the equation of the line, since this line here passes through or cuts through our x-axis, so this should be x equal to, and then we have this one as negative 2.5. You can have that as negative 2.5, or you can have it as negative 2 and 1/2. Next one, we go for the axis of symmetry. So we have the axis of symmetry will be always passing through our vertex and the focus. So this line here cuts through the y-axis. So this should be y equal to, and then the value that we cut here on the y-axis is 1. So next we are going to draw or locate our endpoints of the latus rectum. So again, we are going to double our a. So 2a, that's equal to 2 times 1/2. And then 2 times 1/2, that is equal to 1. So we will be counting from the focus here up and down 1 unit. So this will be now from the focus 1. So this is our endpoint. And then from the focus again, we count 1 unit down. So we have this as our endpoint. So we've got the latus rectum endpoint as negative, sorry, let me just, okay, here, negative 1.5. So we can have it as negative 1.5 or negative 1 and 1/2, or you can have it as negative 3/2. So let me just have it as negative 1.5. And then our y for this one is on 2. And then another one is with the same thing. We have still 1.5 for that one. And then we have our y value here, which is a 0. Since our endpoint here lies on the x-axis, so y will be 0. All the time, once you've got a point there that lies on the x-axis, you have that one as y equal to 0. So next one, we are going to identify the length of the latus rectum. Length of the latus rectum, as I mentioned, you are going to consider this one as your value, so that should be equal to 2. Or if you want to solve that one really, you can have it as 4 times 1/2. That is equal to 4/2, so this is equal to 2. And then we try to graph that one. So from the vertex, we connect with our endpoint and draw an arrow. And then from the vertex to another endpoint and then an arrow. So there you go with your parabola. So I guess that's it for this one under the parabola. I hope that you are going to like, share, and subscribe on this particular video. And then always remember that you have to practice so that you'll get all the hard topics.